Okay, so now we've seen the AP database, and that's what this chapter is using in the book. So I recommend working through the exercises in the book, the examples in the book with the AP database. But I'm going to switch over to a different database for these videos. So I'm going to start with go. So let's use names, which is what I used in last week's videos. And then we'll do select star from names. And I've gone ahead and opened the names database and opened the tables. There's a name counts, names, and your gender totals. If I open the names table and look at the columns, I should see name ID, name, and metaphone. So if I execute this, execute both of these lines so that I'm using the right database. So here's what I get. Now there's quite a lot of rows here, so let's actually scroll to the bottom, and 93,000 rows, so that's middling. In some of the other tables there are even more rows, so I'm going to go ahead and use name counts. So let's do a select star from name counts, and I'm using tab for command completion there. Execute, and this is going to take a while. So that did take a minute or two, probably, maybe a little less than that. But I'm going to go scroll to the bottom. So 1.7 million rows, which not huge, but it's significant. It will take some time, particularly if you're executing a complex query. And if there are multiple students who are all hitting the database at the same time, it can really get slow. So what we want to do instead of using select star against a database with any real size to it is we want to restrict the number of rows that are coming back. And so I'm going to use select top 50 star from names and select top 50 star from name counts. And if I execute these two commands, they come back much more quickly. Now usually this is enough when you're developing the query, and so you can get everything right in the query with the top 50 in there and then switch over to an unrestricted version if it makes sense to do that. But as a self-defense thing, you definitely want to restrict the output coming back. Now, when I use a command like top 50, the question is, well, okay, so which 50 are the top 50? And let's look at the ordering, the way this stuff is ordered. Each table is going to have something called a primary key, which we'll learn more about later on. But basically, it's the main index for storing and retrieving information out on disk for this table. And for the names table, the primary key is the name ID column. And so that's how the data is actually physically stored out on disk in order by name ID. For name counts, the primary key is this ID column, and that's how data is stored out on disk. And so that's the order that stuff comes back in when I do a query on name counts. So what I'm going to get basically is the top 50 rows, the first 50 rows from the database based on how the stuff is stored out on disk. But that's not always what I want. So for example, let's go to the name counts table instead, and let's ask, well, what about if I wanted to know the names where that name had the highest name count? So I want the top 50 rows from name counts, but I want them ordered by name count in descending order. So let's go ahead and select top 50 star from name counts. Oops, I'm sorry. From name counts. And then I'm going to add another clause, which always comes after this from here, and will also come after where when we learn about that. But order by, and now I have to type everything over again so that it lines up. Order by, and then I can say what column I want to order by. So this is going to be name count. And then I can So by default, this will be in ascending order. And if I ran the query right now, I'd get the top 50 rows from name counts, but I would get the ones with the lowest values for name count. So ascending order means lowest first, so the top 50 is going to be the lowest values. If I want the highest values, I can also add DESC for descending. So let me go ahead and execute this query. And what I got back is the 50 rows from name counts that have the highest value for this name count column. You'll see they're in descending order by name count, and I have the highest values first. I could take this ID here and I could look it up and figure out what it is, but we'll talk about that more later when we get to writing queries over multiple tables next week. For now, I've created a view called All Data, and I can say select top 50 star from all data, order by name count, descending, and this will show me some data from name counts, names, and your gender totals. So let's see what we get here. Okay, so same name counts as I got before, same ID and the rank, name ID, those are probably all the same. But now I also have some data from the names table. I have name ID, name, and metaphone. And I also have some stuff from your gender total. So what does this mean? This means the most frequently given name, at least as far as name count is concerned, was the name Linda with the metaphone LNT. Year, gender, total ID. So this in 1947, more female babies were given the name Linda than any other name since this data was collected. And then the most common baby name for males was actually in the year 1947. The number one name given to male babies was James. Number 2 was Michael. Number 3 was Robert. 47 and 57 were good years for babies. It was the so-called baby boom. So this gives me the way to restrict the rows coming back and also to specify what order I want the rows sorted in before restricting them. So let's go ahead and close that batch and we'll start a new one. So this time I'm going to do basically the same thing, except I'm only going to select certain columns. So I'm going to select top 50, and then let's go for name count, and year, and gender, and then name and metaphone. From all data, order by name count, descending. So same thing, I've just selected a subset of columns. And so here's what I get, just a subset of columns. But now, instead of having separate columns for name and metaphone, let's say I want to format this a little more. So what I actually want is Linda space and then open paren, the metaphone, close paren. And I want that to all be in one column. Well, I can do that as a string calculation here in the select clause. So I can say name plus, and then I'll do space open paren, and then plus, and now I'm going to add the metaphone value, and then plus, and then closing paren. So this isn't going to have a column name because it's a calculated value, but let's execute it and see what we get first. Okay, so this is what we get. It's what I wanted. I want to give it a column name though. So let's do as name open paren, metaphone, close paren, like so. So there we go. Now, in addition to calculating name plus metaphone, I can also calculate some more interesting statistics on some of these other columns. So let me open the all data table and look at the columns. And I see that in addition to name count, which is how many times a particular name was given to babies of a particular gender in a particular year, there's also year gender total ID, which is how many total baby names were given to a particular gender in a particular year. So for example, I had 99,000 babies named Linda in 1947. You go ahead and add year gender, actually, what is it? Actually, just the total here. Year gender total ID is the ID of a record in the year gender total table, but total is the total number of names given to a particular gender in a particular year. So let's execute that now. And let's say that I want to rank these not by name count, but I want to derive the percentage of times, percentage of babies that were given a particular name, because there were different numbers of babies born each year. And what I'm actually interested in here is the percentage of babies that were given a particular name rather than just the raw count. So first thing I want to do is I want to calculate name count divided by total to get a percentage. And then to get a percentage, let's multiply by 100. And let's do that. So I'm going to take name count times 100 divided by total, and that's going to be as percentage. So let's go ahead and execute that. And here I get a percentage as well. So we see that 5.6% of babies, female babies in 1947 were named Linda. Almost 5.2% of male babies in 1947 were named James. So 1 in 20 people born in 1947 were named Linda or James. Now I can also order by this percentage here. So there's two ways of doing that. I can do order by, and then I can repeat this calculation here. Name count times 100 over total, descending. So this will work. But it's a little more concise. Actually, that didn't work. What did I get? Oh, it did work, but now the percentages, there's higher percentage names than Linda. And so when I order by this percentage, Mary floats to the top. So Mary's actually the most popular female baby name for, it's like looking like 1915 on through maybe 1924. 25, 28, so right around there, 26, 27, 28, 30, maybe up through 32. Yeah, 1930. So probably from 1914 through 1930 or so, Mary was a popular baby name. And then, let's see, we got Linda in 48, Mary in 31, Linda, Mary, lots of Lindas and Marys. Anyways, so that's one way of doing it. Another way, which is kind of a shorthand that works in SQL Server but not necessarily all different databases, I don't think it works in MySQL, is I can actually repeat this column name here. So I've done this calculation and given the column name percentage, and then I can just use percentage here as well. Even though that's a derived value, this will work. So I get back the same results. It means the same thing as what I did before, but it's a little more concise because I don't have to repeat the calculation. Now, if I go back, I'm going to go back and repeat the calculation here. And the reason I want to do it this way this time is because I don't just want to output this number, but I want to add a percent sign to it. So let's start by making sure this works and produces correct results. And it does. And now I'm going to do something that doesn't quite work. So I want to add a percent sign to the front. So let's go single quote percent plus that value. And that looks like it would work, but in fact when I execute it, I get an error converting data type varchar to numeric. So here's what's going on. This thing here, that's a varchar, character string literal. It's actually a piece of text of variable length. And this thing here is a number. And it's trying to add a string to a number, basically. Now, many programming languages, when you try to do that, it's automatically going to convert the type of this thing to a piece of text. But SQL doesn't do that by default. It gives you an error instead. So to make this work, I have to convert this thing to a piece of text before adding this percent sign to it. And there's a couple of different operators I can use to do that. So the one I'm going to use first is called convert. And there's an example of that in the book as well. And the convert command takes a target type, an expression, and then if you're converting dates, it gives you a date style argument, which tells convert how to produce the thing as a piece of text, basically. Since I'm converting a number and not a date, I can ignore that third argument. So the type that I want to convert it to is actually a piece of text. And so I'm going to convert that into char, and then I have to give a width. So how wide do I want it to be? Well, let's look at this. That's about 1, 2, 3, 4, 5, 6, 7, 8, 9, plus a dot, 10 characters. So let's give it a 10 to start with. So 10 character wide, numeric, 10 character wide piece of text, and then I'm adding the percent to that. So let's go ahead and execute that. And there I have my result. Now, some of the conversion functions you use will actually let you do a little bit more than this. So I've given it a 10 character wide thing. Let's say I wanted to give it, truncate it. So now I'm going to give it 5 characters wide. And so it's going to take the 5 characters off the left. And actually I get an arithmetic overflow because this value will not fit into 5 characters. So what do I do about that? Well, there's different type conversions that I can use. So one handy one is called stir. So stir is going to take an expression, which is a floating point value, a length, which is how wide I want that thing to be, and then scale, which is how many digits I want after the decimal point. So let's say I want to take something that's going to be, let's see, 3 plus 4 plus 5. Let's say I want something 6 wide with 2 values after the decimal point. So this is handy like if you're formatting currency. Execute. So what this did was it converted this number into 6 character wide piece of text with 2 values after the decimal point, and then it added a percent sign to the front. But you'll notice that when I converted it into something that was 6 characters wide, I got 2 spaces to fill out these values that, only have less than 10. And so what I want to do before adding this percent sign to the front is I want to trim off the spaces on the left-hand side of this converted value. So we saw before we could use ltrim to do that. And then I'm going to execute that. Okay, so there's the correctly formatted percentage. Now I want to point something out about this. So here's the order stuff happens. So multiplication and division happen at the same time, so you work left to right. So the first thing it does is it multiplies that times 100, then it divides by total, and then it takes that value, whatever it is, and converts it into a piece of text. And then it takes whatever piece of text is returned by this, trims off the spaces, and then it adds the percent sign to the front. So the order is to work from the inside out on these function calls, and then left to right, multiplication over addition, and multiplication and division over addition and subtraction, working left to right.